This is lesson 7 of chapter 8, and the title of this lesson is Surface Area of Pyramids. We go back to the essential question, how do measurements help you describe real-world objects? And throughout this chapter, we've been talking about how we can readily apply the principles that we learned about circles, areas of prisms, areas of pyramids, and volume with the things that we see all around us. And this lesson is no different. So before we do that, however, we need to understand two words here, slant height and lateral surface area. The definition of which is right there. Okay, so there are three terms we want to find out: lateral surface area, the slant height, and the regular pyramid. We'll be tackling these two first, and we'll go to the regular pyramid in a few minutes. So the ancient Egyptians built pyramids such as the one shown in the photo below, this one right here. Okay, uh, a right square pyramid has a square base and four isosceles triangles, okay, that make up the lateral faces. If you look at this pyramid right here, for example, this pyramid, it will have a square base. Can't readily see the square base, but it's right under there, something there. And it will have four triangles that surround it. Okay? So use your imagination on that one. So it'll have four isosceles triangles, meaning two sides are congruent, that make up the lateral faces. Now, what is a lateral face? Again, it is a triangular face of a pyramid. And this is where we talk about lateral surface area. So when you add up all the lateral areas of a pyramid, you have a lateral surface area, or simply it is the sum of the areas of all the lateral faces. Okay? And in each triangle, you will have a height. So that lateral face will have a height, and we call this height our slant height. So the height of each lateral face is what we call the slant height. Why is it called the slant height? Because if you take a look at this pyramid right here, this is our slant height, and it is actually slanting. That's why it's called the slant height. So let's fill in the blanks in the diagram below with the term slant height and lateral face. We already discussed that this is a lateral face right here. Okay, so we'll write down lateral face. Okay, and this is also a lateral face right here. This is the height of our lateral face. So this is called our slant height. Okay? Now, draw the net of the square pyramid. So if you want to draw the net, remember, a net is simply when you have a particular prism or pyramid and you open it up, okay, that's what forms the net. If I'm going to draw a net of this particular pyramid, the first thing I'm going to draw is the base. And the base is a square, so I am going to create a square base. Oops. Okay, let's do a square base. There you go. Oops, make that a square. There you go, that's a square base. And remember, it has four triangles, which we call lateral faces. So this is a lateral face. Okay, just copy that because they're all going to be the same. And this is another lateral face. Just flip it. Another lateral face. Let me paste it again. Put that here, and then we're just going to flip it. There you go. And one more lateral face. Let's flip it. Put it there. Okay? That is the net of our pyramid. Now, imagine this. If you get the vertices of each of these triangles and pull them up, and they meet in the middle with a common vertex, that will form a pyramid very similar to this one. And if you notice too, okay, this is a lateral, or sorry, our slant height. The one in red is our slant height of our square pyramid. Okay? So that is the net of our pyramid right here. So I just opened this up and it looks something like that. Let's take a look at the lesson proper here. When you talk about surface area of a pyramid, okay? So when you discuss the surface area of a pyramid in words, basically what it's saying is that the lateral surface area, or LA, of a regular pyramid is half the perimeter of the base times the slant height. Now we're going to talk about that a little bit later on. At the bottom, we're just summarizing this lesson. Again, the lateral surface area, okay, of a regular pyramid, we're going to talk about what the regular pyramid is half the perimeter of the base times the slant height. So its symbols look something like this. That's our lateral surface area. 1/2. P represents the perimeter. L represents our slant height. Okay? And when you talk about that in words, this is how it looks like. So the total surface area, SA, of a regular pyramid is the lateral area, which is our LA right here, lateral surface area, plus the area of the base. Remember what big B stands for. Big B stands for the area of the base. Okay? So big B represents the area of the base. So when you talk about that in symbols now, the total surface area of a pyramid will comprise of the base, which is the area of the base, plus the lateral area, okay, of the pyramid, okay, the lateral surface area. So, or surface area is equal to big B, which is the area of the base. Okay, we can have different shapes of the base, that's why it's still big B. And we substitute LA with 1/2 times the perimeter times the slant height will give us this formula for finding the area of our, okay, surface area of our pyramid. There you go. So big B times 1/2 the perimeter times the slant height. And this is the model. Again, this is our slant height. Okay, this is our base right here, and these are the lateral faces, which when you add them up becomes our lateral area. Okay? All right, let's talk about that particular formula in terms of what a regular pyramid is. Okay? Because that's a term that you need to understand as well. So when you talk about regular pyramid, a regular pyramid is a pyramid with a base with a regular polygon. Now this one you need to remember. I think you studied this in 6th grade. When you talk about a regular polygon, okay, this is a polygon with all the sides congruent. Okay, so a good example is a square. All the sides are congruent in a square, so that's a regular polygon. An equilateral triangle is a regular polygon. For as long as all the sides are congruent, that's what we call a regular polygon. And when a pyramid has a base that is a regular polygon, we call that a regular pyramid. Okay? So again, let's take a look at the model of a regular pyramid. In this case, this is a square pyramid because the base is a square and it's also a regular polygon. So this is the lateral face, the base, this is the slant height, and that's our vertex. So if we create net of our square pyramid, this is how it looks like. So the net of our square pyramid now, when you open it up, again, this is our base, These are the four lateral faces of our pyramid, the triangles, and this is our slant height. Remember, the slant height of this pyramid will all be the same. So this slant height is equal to that slant height, and that slant height, and that slant height. Okay? Okay, now let's dwell on this further to find out how we found the formula for total surface, the surface area of a pyramid. So in this case, to find the lateral area of a regular pyramid, we refer to the net. So this is our net. The lateral area is the sum of the areas of the triangles. So we get the area of all four triangles right here. Okay, that means we get the area of all four triangles. We use the formula area equals 1/2 base times height. Okay, so what do we notice? Okay, in our formula for 1/2 base times height, okay, we consider this to be our base, and we consider this to be the height of our triangle. But according to our pyramid, okay, this is considered to be the side length. So our base is also equal to our side length, or our S, and our height is actually equal to our slant height, or our L, right there. So if I'm going to use the formula 1/2 base times height and substitute S and L there, okay, this is what's going to come out. So I'm going to have 1/2 times the base, which is the side length, and the height, which is the slant height. And I multiply that by 4. Why 4? Because there are 4 triangles. Okay? Okay. From there, we use the commutative property of multiplication. Okay? Using the commutative property of multiplication, we do 1/2 times 4s times L. And we know that 1/2 times 4 is 2. Okay? Right here, the perimeter of the base is, formula for perimeter of the base is 4s. Okay? So we know this. 4s is also equal to, perimeter is equal to 4s. Remember the perimeter of a square. This is how you find the perimeter of a square. 4 times the number of sides. And we simply substitute 4s with b. Okay, and that's how you find the formula for lateral area of our pyramid. Okay? And we go to the total surface area of the regular pyramid is the lateral surface area plus the area of the base. Remember, we only found the area of our lateral faces, the sum of the area of our lateral faces. But if we want to find the total surface area, we need to add the area of our base. Okay? So knowing that, the total surface area formula is given as capital B, which is the area of the base, plus 1/2 the perimeter times the slant height, which is also the lateral area of our pyramid. Okay, and this is how the model looks like. Okay, this is our slant height, we know that. This is the area of the base, whatever this is. And the perimeter is simply the sum of all the sides. Okay, so to be able to find the perimeter, you need to add up all the sides. And that's how you came up with this formula, which is right there. Okay, memorize that formula because this is not going away, boys and girls. This will come back to you in high school, in 8th grade, and so on and so forth. Okay, let's take a look at example number 1 and see how it works. Find the total surface area of the pyramid, round to the nearest tenth. So again, we have that pyramid. We have a slant height, which is 9 inches. Okay, we have a regular pyramid because you have a square. How do I know it's a square? Because the sides are the same length. That means everything is the same. So this is a regular square pyramid. Okay, So let's find the formula first, which is area of the base plus 1/2 PL, P being the perimeter, L being the slant height. Substitute the values. Our base is 16. Why? Because the area of a square is S squared, or 4 times 4, which will give us 16. Okay? And then the length, or the slant height, I'm sorry, will be 9 right here. So we multiply it by 9. So multiply all of them, simplify that, you end up with 88. Okay, so this air surface area of this particular pyramid is 88 square inches. Remember, we're talking about area here. Okay, so make sure that you are using the correct units. Okay, all right, let's take a look at example number 2. And example number 2, it's asking find the total surface area of the pyramid with a base area of 111 square uh, square meters. Okay, so find the total surface area of this pyramid with a base of 111 square meters. So in this case, we don't even have to compute for the base, because right now we know that capital B is equal to 111 square meters. Right there, tells us right there. So all we need to do is basically find the lateral area of our pyramid. So what do we do? Again, we go back to the formula, capital B times 1/2 PL. Okay, we know what B is, we substitute that. Okay, we know the perimeter is 48 because I add 16 plus 16 plus 16. Again, this is a regular pyramid because it has an equilateral triangle. It has a regular polygon as the base. 48 now will be our perimeter, 20 will be our slant height right there. Then we simply multiply all of them. We end up with the surface area of 591 after we simplify that expression. So the surface area of our pyramid is 591 square meters. Okay? All right, let's take a look at how to do number 3. Find the total surface area of this pyramid. Again, we have a regular pyramid because we have an equilateral triangle. Okay, if you notice, it's 10, 10, and 10. Okay, so first things first. Okay, write down the formula. Base, capital B plus 1/2 times P times L. Okay, surface area of our pyramid. Next, we substitute. Area of the base is 43.5. How is that? Because if you notice, okay, we have a triangle as our base. This is our base. Oops, let's fix that right there. And you notice too, if I look closely at our triangle, this is our height. Okay, that's our height. Okay, so this is our base, that's our height, this is our base, which is that one right there. Our height is given, which is that arrow right there. So if we do that, 1/2 area of a triangle we know is 1/2 base times height. So we get the base, which is 10 feet, the height, which is 8.7 feet, multiply it by 1/2, we get 43.5. And that's exactly what we have here. Okay, perimeter is simply adding 10 plus 10 plus 10, which should give us 30, and the slant height is 12, right there. Okay, simplify this whole expression, we end up with surface area of 223.5. So the surface area is 223.5 square feet. Okay? Do got it problems A and B, and let's see if I understand examples 1, 2, and 3. Finally, let's finish this off with example number 4. And in example number 4, this is a word problem as always. Sal is wrapping gift boxes that are square pyramids, okay, for a birthday party. Okay? Not really a birthday party, for a party favors, I'm sorry. They have a slant height of 3 inches, base edges of 2.5 inches long. Okay? How many square inches of cardstock are used to make one gift box? So again, this is a classic example how this is a real world situation and we are applying the formula for surface area of a pyramid. Okay? So what do we know? Let's find out what we know here. It has a slant height of 3 inches. It has base edges of 2.5 inches long. And how many square inches of stock is required? So that's asking basically for surface area. So let's find out. Write down the formula first. B plus 1/2 P times L. Okay. And we know that our base, okay, is 6.25. Okay. Our perimeter is 10. How do we know it's 6.25? Because it is a square pyramid. Right there, it mentions there that it's a square pyramid. And if it has 2.5 inches as side edges, formula for a square is S squared, which is 2.5 squared, okay, or 6.25. That's where that number comes from, okay? Now the perimeter, since it's a square, perimeter is the sum of all the sides, so it's 2.5 plus 2.5 plus 2.5 for plus 2.5, or simply, if you want to find the perimeter of a square, it's 4s, or 4 times 2.5, which gives us the value of 10. Okay? And it's given that the slant height is 3 inches, so we simply substitute L to 3 right there. Okay? So simplifying that whole expression, we now have 21.25. So the surface area is 21.25 square inches. We need that much cardstock, okay, to use to make one gift box. Okay? All right. That's the end of our lesson. Do the final, got it, letter C, and let's see if you understand example number 4. And we are done. Thank you for watching.